Welcome student. In this lecture we are going to cover about all the measuring instrument. First we are going to talk about Wheatstone bridge. Wheatstone bridge, this is a Wheatstone bridge. It is in the form of a quadrilateral. It is an arrangement of 4 resistance used to determine one of the resistance in terms of remaining 3 resistance. These are the 4 resistance connected in the arm AB, arm BC, arm DC and arm AD. This is a variable resistance. Its value can be adjusted. This is unknown resistance and these two are said to be a ratio. The arms of P and Q are called a ratio arm. Arm in which R is contained is called standard arm and S is a unknown arm. So a battery is connected between the terminal A and C. These 2 points, a battery of EMF is connected through a key. So R is a variable resistance and it is so adjusted there is no deflection in the galvanometer. When key is closed now, current will flow here, current will flow in all the branches, and this variable resistance, when key is closed, the galvanometer shows presence of current, that is the current through this galvanometer, IG, presence of IG through the galvanometer. So by adjusting the R so that the current flows in this branch is equal to 0, that is when R variable resistance is adjusted, no current flow in arm BD, that is galvanometer will not show any deflection. So now the bridge, when there is no current flowing in the arm, that is no current is flowing in the arm, the bridge, that is the Wheatstone bridge, is said to be balanced. It means no current is flowing in this arm. It means this is said to be balanced. Under this condition, when IG is equal to 0, the bridge is said to be under balanced condition. When it is in balanced condition, the given condition is the resistance P divided by Q is equal to resistance R divided by resistance S. Since P, Q, R are known value, by knowing the value of P, Q, R, we can calculate the S. How we can calculate S? S is equal to R into Q divided by P. This is the value of unknown resistance. Here we have to remember one thing is that when the bridge is under balanced condition, the potential difference, when there is no current flowing in this branch, it means the potential at B is equal to potential at D. Under balanced condition, potential at B is equal to potential at D. Why? Because no current is flowing. Whenever there is a potential difference between B and D, then only current will flow. Suppose this is at higher potential, this is at lower potential, current will flow like this. If this is at a higher potential and this is at lower potential, current will go like this. But when there is no current, what is the potential? Potential is equal to I into R. So since Ig is equal to 0, V is equal to 0 into R is equal to 0. It means both the VB and VD are at same potential because no current is flowing. When no current is flowing means there is no potential difference. That is, if it is 5 volt, this will be also 5 volt. Under balanced condition, no current will flow in this arm BD under balanced condition. This we have to remember this fact in Wheatstone bridge. When we remember this fact, it is going to be helpful for understanding the meter bridge and meter bridge which is going to follow in the measuring instrument in the following lectures. So under balanced condition of the Wheatstone bridge, under balanced condition of Wheatstone bridge, Ig is equal to 0. That is, current through this branch is equal to 0. It means, suppose let us say this is the current flowing from the battery, and here I1 is current is flowing here. Here I2 current is flowing. Here Ig is going. It means I1 minus Ig current will flow here. Here I2 plus Ig. It means here I2 plus Ig is flowing as per the KCL. At this point, I is flowing as I1 and I2. Here, this is entering. It means Ig is flowing here. It means I1 minus Ig will flow here. Here, Ig is coming. Here, I2 is coming. So when the both are incoming, then the outgoing is I2 plus Ig as per the incoming KC Kirchhoff current law, I2 plus Ig, and this will be I. So it means at junction A, I by KCL, Kirchhoff current law, I is equal to I1 plus I2. I is equal to I1 plus I2. Now we will apply KVL across in the loop, KVL in the loop A, B, D, A. This branch A, B, D, A. We apply KVL. KVL means what? We are going from here to here, here to here, here to here. Since the current is flowing from here to here, this will be positive, this will be negative. Current is flowing, this side will be positive, this side will be negative, where it has got a resistance of galvanometer resistance G. And we are coming this way and this way. This side will be positive, this side will be negative because current is flowing from here to here. Let us say A to B. A to B, what is the A to B? It will be positive voltage because we are going from positive to negative. That is, what is the voltage across this one? I1, because voltage is equal to I into R. Here I1 into P is the voltage. It is a positive voltage because we are going from positive to negative. Again, we are coming from here to here. It means this side is positive, this side is negative. So here positive, that is Ig into galvanometer resistance. G is equal to galvanometer resistance. I1G, we are coming this way and this way. Again we are going this way. This will be negative voltage because we are going from negative to positive, is equal to minus I2 into R is equal to 0. Or we can say I1P minus I2R plus Ig into galvanometer resistance is equal to 0. First equation. So under balanced condition, Ig is equal to 0. It means this is equal to 0, or we can say I1P minus I2R plus 0 is equal to 0, or we can write I1P is equal to I2R. I1P is equal to I2 into R. This is, we can have this first equation. Now again we will go BCDA. Apply KCL. We will apply KVL for the loop BCDA. B, C, D and B. So our path is from here to here, here and here. So current is flowing from here. This will be positive side. this will be negative side. Current is flowing from here, this will be positive side, this will be negative side, and the current is flowing as it is, we have marked it. We are coming, our path is BCDB, B to C. It is positive to negative, we are coming, it is a positive voltage, that is current through is current I1 minus Ig into what is the resistance Q, that is V is equal to I into R. Again we are this way, again we are coming this way, that is negative to positive, so that will be negative voltage. When it is negative voltage, current, what is this, I2, that is I2 plus Ig, this is the current, and resistance is S, and again we are going this way, negative to positive, so this will be a negative voltage. Negative, what is the voltage? This is the, what is this current? This current is Ig current into resistance is galvanometer resistance is equal to 0. So we have completed the, see, you are going through this path, plus to minus means plus positive voltage, minus to plus means negative voltage, simple. So since Ig is equal to 0, under balance condition, so this portion is equal to 0, this is also 0, and this is also 0, we can write I1Q minus I2S is equal to 0. This is second equation, and first equation is I1 P minus, so or we can write this as I1 P is equal to I2R, first equation. This is I1Q is equal to I2S, second equation, we can write it like this. So this is the first equation, this is the third equation. Divide 1 by third, 1 divided by third, this and this, P by Q is equal to R by S. When we divide R, the unknown resistance is equal to R into Q divided by P. So therefore we can, when the bridge is in balanced condition, the current through this branch is equal to 0. Under balanced condition, this divided by this, that is P divided by Q is equal to R divided by S. This is very, very important result under balanced condition of bridge. Balanced condition of this Wheatstone bridge. So with this we will be using this result for board as well as for board numerical, as well as many numericals have come based in for NEET and JEE based on the result. Under balance, we have to check up whether the bridge is in balance condition or not. Accordingly, we have to proceed. Now we are going to discuss about different forms of Wheatstone bridge. This is the way how we draw the Wheatstone bridge. First, let us see this one. This circuit also equivalent to Wheatstone bridge because between A and B we connected resistance P. Between A and D R resistance is connected. Between D and C S resistance is connected. Between B and C Q resistance is connected. When bridge is balanced, when bridge is balanced, what are this? Ig, current through galvanometer is equal to 0. It means current through this galvanometer is 0. That is current between B and D is equal to 0. So we can remove this branch. Second one, between A and B, P is connected. Between A and D, R is connected. And between D and C, S is connected. Between D and B, galvanometer is connected. And between B and C, Q is connected. So this is also equivalent. circuit, when under bridge and when bridge is balanced condition. That means the bridge which is having the galvanometer, it can be removed. So the remaining circuit will be like this. Now it means this and this are in series, and these and these are in series, and this will be parallel. Now third one between A, this also point A, between A and D R is connected, between A and D R is connected, between A and B P is connected, between A and B P is connected, between C, this also point C, between C and D S is connected, C and D S is connected, and between C and B Q is connected, between C and B is Q is connected. Under balanced condition, this galvanometer which is connected between B and D, the galvanometer which is connected between B and D can be removed. This can be removed. Under balanced condition only this can be removed. So these are the, when this is removed, the circuit will remain like this. So these are the three different forms, because in the competition examination any types can be given, so that we should be able to realize the different forms of the Wheatstone bridge. Wheatstone bridge is, we are going to use this Wheatstone bridge in for meter bridge. This is one of the first measuring instrument. When the bridge is under balanced condition, under balanced condition means we remove this branch under balanced condition, because no current flow. This one we have already removed this branch, we have already removed this branch. It means A and branch AB and branch BC will be in series, branch AD and branch DC will be in series, and these both will be in parallel. We can draw this circuit like this between A and B. This is point A, this is point B, this is point C, and from A this is point D and this is point C. So this is E, between A and B is P, B and C is Q, this is R and S. So R equivalent, this can be drawn as between A and B, since both are in series, P plus Q, and again this is R plus S, this is point C, this is point A. So both are in parallel. So R equivalent equal to multiplication of both the resistor R plus S divided by addition of this, that is P plus Q plus R plus S. This is the equivalent resistance of this Wheatstone bridge when Ig is equal to 0, that is when Wheatstone bridge is under balanced condition. Balanced condition. See here, these and these are in series, these and these are in series, both are in parallel. So this is the net resistance of the Wheatstone bridge when the Wheatstone bridge is under balanced condition. It means we can remove the branch in which the galvanometer is connected.